Okay, let's connect what we're seeing to something from the past. In a vector function, the input is a real number and the output is a vector. For example, this one we just looked at, right? 5 plus 2t. So, sorry, you feed in a t as an input, it's just a single real number as input, and then as output you get this vector 5 plus 2 times input, comma 9 plus 3 times input, comma 1 minus 4 times input, all in angle brackets. So you get that vector. So for example, if I didn't make any arithmetic errors, then r of 2 should be the vector 9, comma 15, comma negative 7. Now let's think about parametrization. When you're given a real number, each coordinate is described separately using a separate formula, right? So as for example, our parametrization is x equals 5 plus 2t, y equals 9 plus 3t, z equals 1 minus 4t. If you stare at it in this format, you might recognize this parametrization as being a parametrization of a line in three-dimensional space. And when you plug in t equals 2, you get the point 9 comma 15 comma negative 7 here now in parentheses. So you see how the vector function, when you plug in the input 2 into the vector function, we should use we should use function language, inputs and outputs. So you plug in 2 as an input and you get as an output the vector 9, 15, negative 7. And for the parameterization, when you plug in time 2, you plug in the time being 2, you get the point 9 comma 15 comma negative 7. And here's that correspondence we've talked about loosely before, the vector that corresponds to the point that corresponds to the vector. How different are these? Yeah, they're technically different. There's technically kind of lots of differences going on, but morally it's the same, right? So in the view that every point corresponds to a position vector, so the position vector which starts at the origin but ends at whatever that point is that it corresponds to, a vector function can be repackaged as a parametrization, and a parametrization can be repackaged as a vector function. I'll just say something that may help for those of you who've done a little bit of computer programming. If you're computer science minded, you might just say that these are different data structures. So they're technically different creatures going on, vector function versus parametrization. But just loosely speaking, they're storing ultimately the same amount of data, right? Like when you talk about a specific t value, and that's I think why the book author tended to use t for the input label to a vector function instead of using an x, I think to remind us of parametrization. But when you feed in a specific input to a vector function, for instance 2, um, that's your sort of input information. Just like in a parametrization, if you want to get a specific point, you need to specify a certain moment in time. So you specify like 2 hours after midnight, t equals 2. Then now let's talk about the other side. What do you get? So in the case of a vector function, you get a certain vector as output, like in this example, 9 comma 15 comma negative 7 in angle brackets, versus for a parametrization, these three separate formulas the results get stuck together as the coordinates of a point. So it's the same amount of data, 9, 15, negative 7, right? Three real numbers as data, but technically they're different because one's a vector and one's a point. And that's what I mean by different data structures, right? So ultimately, the same amount of data in, for instance, a single real number, 2 for both of these, um, and the same amount of data out. The three components of a vector are all real numbers, and the three coordinates of a point are all real numbers. Okay, let's continue this idea. Consider x equals 5 plus 2 cosine of t and y equals 9 plus 3 sine of t. That parameterizes an ellipse, and just taking the x formula and the y formula and then throwing them in as the components. I copy pasted to create the components of a vector function. That's the related vector function. And I left out the of t in parentheses here, as the author might sometimes do. The whole point is that for the same value of t, the former, the up here at the top, the parameterization will give you a point. For instance, if you use pi over 2, you ought to get the point 5 comma 12, and the latter gives you a vector. So if you plug in the input pi over 2 into the vector function here, you ought to get the vector 5, 12. But you can just think of both of these things as the motion of a bug in two-dimensional space, or a particle, an electric charged particle or whatever, right? So you could imagine something is moving around on the plane in the shape of an ellipse.